Hi there. Today I'm going to be talking about what exactly a geologist does. So before we start, I'd like to go ahead and define what geology is and what exactly a geologist is so that we're all on the same page about this. So the American Geosciences Institute defines geology as the study of the planet Earth, the materials of which it is made, the processes that act on these materials, the products formed, and the history of the planet and its life forms since its origin. So I think we all have a good understanding of what geology is, especially now that we're a few weeks into this course. So now that we understand geology, we can better understand what a geologist is. So according to the Bureau of Labor Statistics, a geologist studies the physical aspects of the Earth, such as its composition, structure, and processes to learn about its past, present, and future. So I categorize the focus of geologists into three main categories, and those are Earth's processes. So this would be things like flooding, earthquakes, or other natural hazards. Then a geologist might focus on Earth's materials. So this would be natural resources, metals in the ground, such as oil or natural gas. And then the last area of focus for geologists is Earth's history. So geologists often study the Earth from millions and millions and millions of years ago to understand what's going on now and even more so predict the future. So now I'm going to go in depth in each of those focuses and kind of talk about what a geologist does as it relates to each of those categories. So the first one I'm going to talk about are Earth's processes. So the first area of focus, a geologist might assess natural hazards. So they frequently assess floods, earthquakes, or even volcanic eruptions. And they use past events about these natural hazards to predict the future and hopefully with the goal of reducing suffering or any physical damage that comes up from these natural processes. So an example of this you can see in the image on the right, which I've just highlighted, are flood maps. So this is a flood map that was made after Hurricane Katrina in 2005. So flood maps take information that geologists collect about flooding in the past and use it to create maps that show areas of high to low levels of potential flooding in the future. And so these flood maps are often used by developers or engineers when developing infrastructure in an area. So a geologist would play a huge role in making these kind of maps. So not only do geologists assess natural hazards, but they also monitor human impact on the environment. So they play an important role in assessing the damage of human impact and how that relates to the environment, and furthermore, finding remediation methods. So an example of this would be the siting of major construction projects. So geologists study Earth's processes, but they also study Earth's materials. So a geologist often is involved in the search for natural resources. So this could include water, fossil fuels, and other metals in the ground. They often conduct studies to locate rocks with valuable metals, oil, natural gas, and groundwater. And they furthermore develop resources. So they find ways to extract these natural resources from the earth. So they might, for example, plan a mine and find out ways to get some kind of precious metal from the earth. So Earth's materials and processes kind of make up this big picture of Earth's history. So geologists study Earth's history, and in order to do this, they use clues from the past to understand changes of Earth over time. And one of the main purposes of doing this, and what is very popular now, is to better understand climate change. And so they do that in an attempt to further halt any damage that we've already had to the earth and our environment. And one way geologists monitor climate change is acting as consultants to government agencies and advising them on climate change and other energy initiatives. So on this slide, as you can see highlighted, this is a report made by the Intergovernmental Panel on Climate Change, abbreviated IPCC. And so this is a report about the physical sciences and as they relate to climate change, and a geologist would play a huge role in the information and the writing of this report that would be presented to various government agencies. So now that we understand a big, broad kind of image of what a geologist does, we can kind of break it down and look at more of the micro level of tasks that a geologist might do. And so this would be more on a day-to-day basis, what you might see a geologist doing. So geologists plan and carry out field studies. They also analyze data such as aerial photographs, well logs, and rock samples that were collected from the field to locate deposits of natural resources. So this is a really common task of a geologist. They might also test that data that was collected in the field and take it back to a laboratory. Geologists commonly construct geologic maps and charts, such as this map of Virginia shown here on this slide, and also such as the flood map that I explained a couple slides before this. And then the last thing I wanted to highlight is that geologists often prepare scientific reports. So an example of this is these ones about certain types of rocks and features in the national parks, but also that IPCC climate change report is something really common that a geologist might do. So this is just an example and gives you a good idea of what geologists do on a day-to-day basis. This list is not exhaustive. There are many other things that geologists do, but this kind of gives you an idea across the board of what a geologist might do more day-to-day and on a micro level. So now that we have a better understanding of what a geologist do, I think it's important to understand the environment in which geologists work. So the first thing is that geologists can either work inside or outside. So they might work outside in the field, collecting data, getting field samples, or they could work inside. This might include writing reports like the IPCC report, or they might have a combination of both. So they might collect data from the field and then go back to a laboratory inside and analyze and run tests on that data. So geologists can work both inside and outside, and then there are a variety of sectors that geologists work in. So geologists might work in the industry sector, and they could be working for a private company. They could be working in the government, so for some kind of government agency as a national park ranger, for the Department of the Interior, or all sorts of things for the government. And then lastly, geologists can work in academia, so this might be research or teaching at a university. So as you may have gathered from this presentation so far, that geology and geologists work in this huge, broad range of areas. So in order to kind of focus, you have lots of geologists in these various subspecialties. So in this slide, I just want to highlight some of those subspecialties. So you might have a geochemist, and this would be a geologist that studies the composition of elements found in groundwater using both physical and organic chemistry. There are petroleum geologists, and they explore the earth for oil or gas deposits, often work in mining industry, as this picture shows. There are seismologists, so this is a geology that studies earthquakes and the related phenomena that is associated with earthquakes. There are paleontologists, and this would be a geologist that studies fossils in the rocks. There are even planetary geologists, so not only do geologists focus on Earth, but other planets, moons, and the origin of the solar system. And then the last one I wanted to highlight are engineering geologists. So these would be geologists that apply geology to the construction field and might help with the building of bridges or dams or other sorts of infrastructure, often dealing with the foundation or the site that a piece of infrastructure is put upon. So now I think we have a really good understanding of what a geologist does, the environment that they work in, and all sorts of subspecialties that a geologist can focus on. And I took a lot of this information from the Bureau of Labor Statistics. So this is the job outlook for geologists. And I just want to highlight some of the main points that I found and I summarized in this chart. So the median pay of geologists is actually pretty high. Geologists on average get about $88,000 a year for salary. The top 10% of geologists gets closer to $125,000 a year, and these geologists would work in mining, quarrying, and other kind of natural resource extraction, which you may kind of thought already. The entry-level education for geologists is a bachelor's degree. However, no prior experience in the field is typically required for entry-level jobs. And then in 2016, there were 32,000 geologists employed. And then the projected number of jobs in 2026 is 36,500. And this represents about a 14% increase since 2016. And just to give you a point of reference, according to the Bureau of Labor Statistics, this 14% increase is a growth rate that's much faster than the national average for jobs. So, in summary, as this presentation hopefully has shown you, is that geologists work in a wide variety of fields. There's no one specialty that a geologist really focuses on. In terms of the environment that they work in, they can work in both an office or out in the field, or a combination of both. Geologists range from anywhere from studying fossils to mining to research in academia in a lab, and then even studying the solar system. So huge variety. So now that we kind of understand this, I thought it was really important to note the last thing I talked about was that what a growing field geology is. So it has a really positive job outlook according to the Bureau of Labor Statistics, and a quite decent pay, especially if you compare it to other jobs in the United States. So now that you kind of understand what a geologist is and get a little bit more about the environment they work in, maybe some of you are interested in a career in geology or one of the various subspecialties that come along with it. Thank you very much.